bio-based composite. I've shared this in the first few slides only, that bio-based compounds are getting studied. So any idea about some bio-based fibers?
Wood will be added. Wood grain.
Wood maybe again you are saying wood. So wood can be added as one of the pillar to make some bio-based composite. But in terms of fibers, if I want to ask,
Rayon.
rayon, is it the natural fiber?
Wood pulp is used to make it, right?
Wood pulp, but again it is not maybe as a fiber.
Minerals, talc like.
Oh no, again they are the synthetic compounds. See, have you heard about the jute fibers, or hemp fibers, or flax fibers, or coconut, even coconut fibers, the coconut shell, on coconut shell there are some fiber like compounds are present, right? So these kind of fibers are nowadays also getting studies to make the fiber reinforced composite. So basically the synthetic fibers, that is glass fiber, carbon fibers are there, which are, we can say, conventionally used. For the years and years they are getting used. But nowadays the study is going on, maybe not 100%, but at least maybe partial replacement of these fibers, the synthetic fibers, in which jute is there, hemp fibers is there, coconut fibers are there, flax fibers are there. So these kind of fibers are getting used, and as you have said, you will require some polymer. So along with fibers, you will add one polymer to matrix, we can say, just to matrix to hold that fiber to make the fiber reinforced composite. So this can be unsaturated polyester, but along with unsaturated polyester, it can be epoxies also, it can be some polyolefins compounds also. So these are some applications of the unsaturated polyester. Now the polyamide family, as we have already discussed this, like there are different kind of nylons are present, nylon 6, nylon 66, nylon 16, nylon 46. Again, different monomers needs to be used to make this polyamides. But all again, this nylon, even though there are different like names of the nylons, they all fall under the category of polyamides. So as a last slide I have discussed, in the polyester there are different kind of polymers. Similarly for the polyamides, there are different kind of nylons can be present. Now coming to the resins, maybe it is not maybe that much related to the plastic, but some of the portions, like, or some of these resins, as I already discussed, like fiber reinforced composite. So for this, epoxies can be used. Then alkyd resins are there, amino resins are there, MF. Have you heard about melamine formaldehyde or urea formaldehyde? So which are basically popular in the kitchenwares, this melamine formaldehyde compounds. So they are from the amino resin family. Or in the phenolic resin, maybe you have heard about Novolac or Resol. So they are from the phenolic resin family. Then some silicone resins are there. So this is again from the resin category. And along with this fiber info composite, or to make some composite, this resins can be also used to make the paints or the coatings. So these are some applications of the resins. Now next is elastomer. What do you mean by elastomer? Or what are the properties of the elastomer? Like why, if I want to ask, like polyethylene, why it is not fall under the category of elastomer?
Elomasters are thermoset materials.
Oh, no, sir. Elastomer, if you check the resin chemistry, like if you just epoxy, if you react with the some hardener, then to form this three-dimensional structure, so that maybe it is fall under category of thermoset. But elastomer is different thing. So what do you exactly mean by the elastomer? By seeing the example which is there on this slide, can you just comment about what are some properties of the elastomer? Sorry. Or which is a key property I want to ask?
Elastic property can be stretched.
Elastic property. Yes, it can be stretched. It has good elongation property. But what we can say keyword, you can use good elongation property. Rubber, you can use a normal rubber which you can use for the hairband. So you can stretch it, but it will not get break, right? But thermocol, can you stretch the thermocol? Not possible maybe to stretch the thermocol to such an extent. So this is, we can say, the difference or key property of the elastomer. And these are some example of the elastomer, that is natural rubber, polyisoprene, polybutadiene, nitrile rubber. So these are some properties of the elastomer. Can you just name some applications of the elastomer where the elastomers are used? Not maybe exactly natural rubber is used here, but in general, elastomer, applications of the elastomer.
Tires.
Where?
Tires.
Tires,
Tires.
yeah, tires, yes, tires.
Conveyor
Rubber
belts.
seals.
Yeah, conveyor belts, rubber seals, right? So these are some, we can say
Yeah, we
the
are, yeah. In cable property also using
in a,
elastomer.
yes, so elastomers are used. So these are, we can say, some popular applications of the elastomer where we can say good elongation properties, good stretching properties are required, where you can use the elastomer. Whereas if you check the chairs, the normal chair which you will use in your home, plastic chair, so it should have good wear and tear properties. It should have some good dimension stability. When you sit, it should not get, we can say, disturbed. Its shape should not get disturbed. It should hold your weight. So it should require some good amount of mechanical property, good strength into it. So they are generally made up of this PP work or etc. etc. Or PET bottles we have already discussed, like plastic bottles, transparent plastic bottles, they are made up from the PET. So basically, depending upon your final application, your polymer is going to be changed. It is not like that PE can be fulfill all the properties or all the applications. Or similarly, natural rubber, you maybe you can't make the chair from the natural rubber. The applications are different. You are depending upon your final product, what you want. You have to choose your polymer. Similarly, in the first previous slide, I have checked about, or I have talked about some paint industry. So suppose if you want to apply a paint at your home, you will not use PE or PP. In that case, maybe you will require some acrylic polymers. So based, what I want to convey is that based on your final application, final product, your polymer is going to be changed, your chemistry is going to be changed, and you can generalize the rule that polyethylene I will use for paint also, polyethylene I will use for bottles also, polyethylene I will use for conveyor belt also. No, there are some applications are fixed. Maybe you can do some modifications, some blending, etc., to fit the purpose. But it is not like that polyethylene will use everywhere or natural rubber will use everywhere. So these are some. Then we will maybe today's end last slide here where we are ending today. So that is about the copolymers. So what do you mean by copolymers? Or have you heard about any copolymers? Or full form of ABS? Anyone?
Madam, S stands for styrene. That's what I know.
S stands for styrene, yes.
Butyl, I believe, and S is styrene.
So a full form of ABS or SBR or EVA.
SBR is styrene butadiene rubber, I believe.
Yes, styrene butadiene rubber, good. Now ABS.
Acrylic butane styrene.
Acrylonitrile butadiene styrene. Yes. Then ethylene propylene copolymer I already listed. Then EVA.
Dimonomer.
Okay, ethylene vinyl acetate and EPDM, ethylene propylene.
Dimonomer.
Yeah. So these are some copolymers. Now, what do you mean by copolymers basically?
Actually, it's a different family, madam. Copolymer means different
Family, yes. Okay, so again, as a last question of today, maybe again you can check about the copolymers today. Like what do you exactly mean by the copolymers? Like why ABS is different from ethylene? I hope, is it ethylene, ethylene, not ethylene, polyethylene. So polyethylene is copolymer, yes or no? Is polyethylene is copolymer?
No.
Ethylene
No.
homopolymer.
It's a homopolymer, right? Now ABS, but I have already listed here. ABS is a copolymer. So how these copolymers are different from the homopolymers? That maybe again you can check today. So thermocol ka chemical constituent you have to check. Glass transition temperature you have to check. And what do you exactly mean by the copolymers? That you need to check today. These three questions maybe you can answer me tomorrow. So So here maybe you can we can stop here. So what we have exactly covered today, we have covered about the polymers, then what are the different kind of polymers, then like what is the definition basically of the polymers, then monomer, what exactly mean by the monomer, then how like how the functionality in the monomers can be vary, then how the double bonds basically is helps to open up like to form ethylene to polyethylene, how the double bond is helping to form the polymer that we have covered, then different kind of difunctional trifunctional monomers uh, that we have discussed today, and in the last like last few slides we have talked about different kind of we can say families. We have talked about plastic, or then we have talked about the elastomer. In the elastomer we have seen that it is having the good elongation properties. Then we have talked about one more application of the polymer is fibers. So what do you think, so what properties fibers should have? Is elastomer and fiber is same?
No,
This,
madam.
so
No,
what,
ma'am.
so what properties fibers, polymeric fibers should have?
Mechanical properties.
So which mechanical property?
Ma'am, basically is the hardness and hard material. Fiber, if you called, that is the hard material, and the elastomer is the ma'am, basically is
Soft.
the elongation, is the soft material.
Soft material. Okay. So any polymer which is used for the fiber grade application, and how basically fibers are made, by which processing technique? Do you know about this? Which processing techniques is used to make the fiber? Like suppose if I give you this XYZ polymer, you have to make the fiber from it. So which processing technique you will use?
Extrusion.
Pakka?
Yeah.
Okay. Any other?
While extrusion,
That's why I asked you. Pakka, you want to say the extrusion only?
ma'am, maybe it will be made through injection molding, because injection molding is
How you are
certain
going to
hard
make
material.
fibers from injection molding?
Is the hard material. Sorry.
No.
Yeah, right.
Reactivators through
Sorry. Have you heard about melt spinning, solution spinning, or electro spinning? Have you heard about electro spinning? Melt spinning, solution spinning, or electro spinning? Have you heard about any of this technique?
Mm.
Okay. So basically, these are the techniques. Again, this maybe get covered in the processing, but these are some techniques through which basically you can make the fibers. Like if I give you, let's say, polyacrylonitrile, which is we have discussed just now, that polyacrylonitrile is one of the popular polymer for the fiber grade application. So if I just give you the like polyacrylonitrile, then you can process it by this processing techniques to make the what can I say, to make the fibers of polyacrylonitrile. Now, what do you mean by electrospinning? By name, what do you think? What do you mean by electrospinning, or what can be the components of this technique? By name, what you can guess? Electrospinning. So basically, when we are talking about the electrospinning, as I said, you will maybe do in details in the future. But this electrospinning, if I give you just rough idea, you have to give some voltage. There will be some polymer solution. You are going to pass it through the syringe. You will going to give some voltage, due to which basically the fibers, which may be in the nano form also, are going to come from the syringe. They are going to get collect. You will have some collector at another end. They are going to get collect, and you will end up to get the final like I say polymeric fibers. So this is just one technique I have just explained. In the solution spinning, you have some solution, or you can solvent basically is present, in which you are going to add that polymer. In the melt spinning, you are melting that polymer. In the processing, you are going to melt that polymer. So these are some techniques through which you can make the fibers. So if I just, like I said, to classify the polymer, again, classification we are going to see in details maybe in the tomorrow class. But we have some classifications we have seen, that we have talked about plastics, we have talked about the elastomers, we have talked about the fibers, and we have discussed about the resins. So that's it for the today. So thank you so much.
Madam,
Slides
this-
will be shared after.
Thanks, ma'am.
Yeah, thank you so much.
Madam.
So should I leave? Yes, yes,
So there's one request, madam.
yes.
It's been long since we are in touch with the functional groups, which you